Morning, friends. Hope you all are doing well. Today I'm going to demonstrate you about the SRMS redundancy, segment routing mapping server redundancy. So mapping server we use to push the non-segment routing prefix-sid entries into the segment routing domain. Like if we have some prefixes which are in the non-segment routing domain, it could be the IPv4, LDP or rsvp. And if we want the prefix it for these prefixes in the segment routing domain, because segment routing only understand the prefix it. So in that case, we need some external server. It could be either server, it could be router, the control plane. And this server advertise the prefix to seed entry matching into the segment routing domain. So if we have the single segment routing mapping server in your network, and in case if it fails, then you will not be able to reach the non-segment routing prefixes using the segment routing index. So we should have the redundant SRMS or two or more SRMS in our network to achieve the redundancy. So when two or more SRMS are there in the network, then some criteria should be there to prefer the entry from one of the SRMS server over the other. So if you see the older documentation, there you will see almost 8 steps are there, which prefix has to go through it, and then one of them will be selected as a base. But in the recent versions, so many changes are there, and then only criteria is there to prefer the larger router ID or the larger system ID. And second criteria could be the smallest area or smallest level ID is more preferred. Like if area 0 is more preferred than area 1. But main criteria is the router ID or system ID. So these are the criteria which were discussed in the older documentation, but now only the first two are valid. And while discussing the SRMS, you need to remember only 2 points. One is that larger router ID or system ID will be the preferred SRMS. And if there are conflict in the network in the prefix-sid entries, then router is going to ignore that one and it's not going to install that one. If you see this criteria which was mentioned in the older documentation where these entries are talking about the conflict entries. But in the recent version, if there is conflict, then don't install those prefixes into the routing table. So these two things you need to remember while configuring about the SRMS redundancy. So this is the today's lab where R1 has connected some prefixes which I am going to redistribute into the ISIS, and R5 has some prefixes which will be redistributed into the ISIS on R5. R1 and R5 both are acting as a segment routing mapping server. This is R5, sorry for typo, and both of them are advertising some prefix-sid ranges in the network. And based on the criteria, R5 should be the most preferred SRMS server. But let's say in the configuration section. So this is the debug capture on the R1 router. When we first configure the SRMS on the R1, so client receives those entries and then it insert into the active policy. After that, it start calculating the SID index value for the each and every prefixes. And once it calculates SID index value, it calculates the label for that one based on the sRGB, and it push those label into the label forwarding information base. First we configure the R1, then we configure the R5. So initially it will put all these R5 entries into the backup policy. But once it runs that algorithm or criteria, it figures out that R5 is the best SRMS router. So it will push those entries, uh, R5's entries into the active policy, and then it will push the R1's entry into the backup policy. Therefore, it's going to remove the SID value calculated from the R1, and it's going to calculate those value for the R5, because R5 based on the largest system ID, R5 is the preferred SRMS server in this topology. So as you can see on the right hand corner, R1 and R5 we need to configure it as a SRMS. But if we check the routing table for these all of these prefixes, so we have few of those prefixes advertised from R5. So let's try to trace route them and see if they are running any MPLS or anything. Let's say 20.2.2.2. So 10.1.1.1. So that is purely IPv4. So let's configure the segment routing mapping server for these entries. Let's first try to configure it on the R1. So these three ranges I'm advertising from R1, and then inside the router ISIS I need to advertise those entries. Advertise local. So this is the complete configuration for the segment routing mapping server. Let's commit this configuration. And if we see this packet capture, we should see this packet here. So router R1 is using the seed/label binding TLV to advertise these entries. So if you see here, it is 20.1.1, range is 50, and that's seed level starting is 200. This is for 31.1.1, range is 50, and this is the seed level value for the 30.1.1.1, and this is the seed value for 200 prefix. The range is 1, and this is the seeds or label value for that prefix. So this is how R1 advertises these entry into IGP, and then based on that one it calculates the label value using the sRGB. So if we see show segment routing, show ISI segment routing label table, so we should see the segment labels based on the segment routing for those prefix. So try to trace route using SRMPLS, that is 2111. So we can see that now R1 is able to use this label value, that is 16200 in their network. If we check the preferred entry, show ISI segment routing, prefix-sid map, active policy, and if we go to detail, so R1 is acting as a active SRMS for all of these prefixes. If we check the backup one, so far we don't have any backup configurations. Backup policy, it's not there. So let's jump into the R5 and let's try to configure R5 as a another SRMS. The segment routing, mapping server, prefix-sid index, address family, IPv4, and just pushing these prefixes. And for router ISIs, advertise this. Receive by default it is on the client side, so we don't need to configure the receive, but the mapping server entry we need to advertise on the SRMS. So we need to configure it as a advertise local. So if we see the complete configuration, this is we are configuring the SRMS. So same range whatever we configured on the R1 plus extra prefixes. But there is no conflict I am configuring, because if there is any conflict between R1 and R5, then it's not going to install those prefixes into the label forwarding information base. So this is how I am advertising this SRMS information into the IGP, and let's commit it. And if we see that we should get some LSP, yes, we got the LSP. Where LSP ID is 5. So you can see that all these three entries has been advertised by R5 20 with range 50 and starting label value is 200. This is for 30 and this should be for 100 with a range value 1 and starting seed value is 1000. So if we check the segment routing label table, it will be same, but if we check the active and backup policy, Now for these prefixes, R5 is acting as a matching for 2111, 3111. These two are overlapping entries at both SRMS. So based one is preferred based on highest router ID or highest system ID. So 100 is just only configured on R5. That's the reason it's showing based is R5. And 200 is only configured on R1. Hence it's saying that based is R1. So if we check the backup entry, backup policy. So now you can see those for overlapping prefixes, R1 is acting as a backup. This is backup policy. So here you can see the R1 is acting as a backup policy here. Just to check the conflict, let's configure the one more interface, loop back, let's say 40, IP for address 4111 slash 32, and then configure the overlapping entries for slash 30 and 40, and let's see. So if you see that 30 has these overlapping entries, so let's say 4111 slash 32, let's say 340, range 50. So here it will start from 300 till 350. So I'm at starting for 40, it is 340. Just 10 sit before ending this particular range. So let's see. So we got the config failed error. So it's not allowing us to commit those configuration because it is saying that seed got overlap in this case, and it's not allowing us to commit that configuration. But if it is the prefix overlap, then it will allow you, but it's not going to install those prefixes into the lfib table. But for seed overlap, you will get the commit error for that one.